Hey everyone, in this video, I'm going to take some more questions based on time complexity, and that will help you to get a better understanding of the concept. So, moving on, like what we had discussed in our previous video was based upon the analysis of for loop. The other one was when the value of the variable was updated using by multiplying it via number kind of two or three. And what was its time complexity? If we just have a quick glance on that, then its time complexity was big O of log n base 2. And the same complexity was for the fact when it was multiplied as well as when it was divided. And then we discussed the case of nesting two loops. Now we discussed the case of nesting two loops and how we discussed we took two loops. The first one was running for the time complexity of big O of n. The inner loop was running with the time complexity of log n base 2. This was so overall the time complexity of the whole program segment was big O of n log n base 2. This was the case. This we had taken in our revision. And what we basically took during the start of that video was that when we first we check for how many times the program is running. And it is that first of all, it is to be noticed that the time complexity is not determined by it is not just generally gets too much affected or basically affected by the program or by the line of code that only runs single time. It basically gets affected for iterative functions, loops and all. So like for that reason only, first we have to actually analyze for how many times the program is running. And if we write a for loop that is from for I is equal to 1, I less than equal to n, I plus plus, then that for loop runs for n plus 1 times. And why plus 1 came, that we also know, because for n times the program will run, and for n plus 1 the time, the program will check the condition, and if obviously it won't satisfy that time, so it will simply come out of the loop and it will do the remaining execution. So that makes the code n plus 1. But the big O of and the time complexity is determined by the highest degree term of the polynomial. So the degree is the factor, like if in a polynomial, how degree is determined by the highest, the power of the high coefficient or kind of nth power. Like if the polynomial is given like n square plus n. Sorry, this is, let me make it a square here. So basically, the power is determined by n square. So n square plus n, it is determined. So like here, the time complexity will be, if we take it, then this time complexity will become 0 of n square. Okay. So moving on, like to the next part of our time complexity that we'll be discussing in this video. So like if I ask you after till now, if I ask you like what is the significance of time complexity, like for what purpose we are calculating it. So basically, the answer to this question is that time complexity help us to know, or help the programmers to know how much the program is efficient. Like what the code you are writing, how much is it efficient? Like we can write 1,000 lines of code, we can use any kind of approach to write. It doesn't matter until and unless we just have to keep one thing in mind, is that the program shouldn't run for indefinite time. Like it shouldn't go on keep running and running and running. We have to just neglect that. Otherwise, we can use any of the approaches. So why is it important to know the time complexity concept? So it is important to know the time complexity concept because of the fact that it helps us to determine how efficient the program is. Like what we are writing for a given problem. solution that we are writing, how efficient is that? Like in a general notion, if I just go, though I should have done that in the next video, but it is a very common concept. Like if we want to go from this particular place to this particular place, there must be there might be one way this, the other way this, and the other way this. So let me name these three ways as A, B, and C. This is the place X. This place is simply you can call Z. So this place is X, this place is Z. And to reach to reach the place Z from X, there are three ways: A, B, and C. So out of these, as a person who is standing on the place X will take has to decide out of the three ways which way has he has to or she has to take. So out of this, the way that will decide will be the most efficient one. So out of the three, the most efficient way can be decided on the parameters like which way is the shortest, which way is the less time consuming in the fact of traffic, or other factors. So this is the way. So out of these three ways, the efficient one supposedly is the B. So B's time complexity will be less. Okay. B's time complexity will be less. Sorry, I like this. So like as soon as I will be completing with this the program segment to calculate the time complexity, I will be telling you about the order of how to decide the time complexity. Suppose if you're given two program segments and you have to determine which is the most efficient code. So how you will decide on which factor? So basically you have to calculate the time complexity of both the program segments, and then based upon the priority order, you will calculate which program is a efficient approach. So here B is efficient. So this was a general approach. Now we come to our main part here. So as I told you, I will be if to the continuation of a previous video we were discussing for in that. So I will continue to take one or two questions more of for here. And the very first question here of for is that in last video, the last type of program segment code that we discussed was based upon nesting of two loops. Now here two loops are there, but they are not one inside the other. They are two separate loops. Like one is there, and after as soon as one is done, like it is closed, the curly brackets are there, and after that another loop is written. So let me explain you the code. So for int, or we are supposedly to just mention the variable. Variable can be anything. It can be string, no string, but it can be double, it can be float. So for I, and then I less than equal to n, I plus this. This is the case. Now this loop has got some statements in it. This is one loop, and like since I'm using here, you can call it a Jamboard. I'm using it, so I don't have much space to write another for loop below the other. So I'm just drawing a line, and I'm just writing turnover here. So turnover just simply means that the other part of the program that I'm writing on the next page is also included in the same question. So I will be writing here continue. So when you are watching this video, it should not be a confusion to you. So like I will be writing here for I is equal to 1, I less than equal to n, I is equal to I asterisk 2. So this for loop also has its own statements. Now statements can be anything. It can be sum of two numbers, or it can be sum of this control variable. It can be normal counting. or it can be like system.out.println in Java, or it can be cout, like the variable in C++, whatever it is. Statements can be anything. So here we are supposed to be concerned, like last, like we had discussed in the previous video, when we have been using nested loop. Nested loop is what? When we call nested loop, when one loop is inside another loop, that is known as nested loop. So here is a different kind of a question. Like there are two loops, but the loops are not one inside the other. They are two separate loops in within the same code, or within the same question, within the same program segment, you can call. So here, how we will decide what will be the time complexity of this whole program. So like first, we take one program segment one by one. So for this for loop, we will be calculating here the time complexity. So based upon the knowledge that we have, the time complexity of this program will be big O of n. Clear? So going to the next part, we have to calculate now the time complexity of this part. So as up till now, what we have understood, that when such kind of scenarios will be there, like two loops will be there, but they will be separate. So how we will be calculating the time complexity? First, we will take out the time complexities individually. So here we will be taking out like the time complexity of this. So what will be the time complexity of this? It will be big O of log n base 2. Now, time complexity big O of n is like that the maximum time that your code can take in efficiently. Like big O of here will be denoting the maximum time that your code will take. So half of the programming segment, the first for loop has time complexity big O of n. The next for loop has its time complexity big O log n base 2. So out of which both, these are two separate individual time complexities of the given for loops. So what will be the time complexity of the whole program? So now you have to like, we can't simply write it is like that. There might be a intuition that you will write like O big O of n plus big O log n base 2. One can simply write like this. But let me tell you, this is completely wrong. You can't simply add the two times complexities. This is not the answer. The answer to this question is, first you have to know this concept that the time complexity is the maximum time that your program can take. So like now here comes your what I call is the priority order. So as of now, I'm not going to write the complete priority order because still I have to discuss one or two questions more. But I'm telling you here what is the priority, like that. See, so out of this, when you write the whole priority order line, when you write the whole priority order line, O log n, isn't it? Log n comes like if we go on like this, the scale of measuring is this. So first O of log n comes, then On comes. So based upon this concept, the increasing, this is the path of, if I write this is the increasing order. This is the increasing order. So based upon this concept, what will be the time complexity of the given program? Obviously, if O log n comes before On, then your time complexity is determined by the maximum time. So in that case, the maximum time will be obviously the time complexity of this program. That is the time required by this program to run is big O of n. So hopefully this is clear. So now moving on to the next question that is based upon the for. We will be taking one question based upon for, and the other part will be based upon while. So we are taking one question of for. Now, up till now, we have discussed the time complexity in case of for loop, considering the updation. Like we have taken, if we have declared the variable I, then we have simply taken I asterisk 2 or I is equal to I by 2. But here we will be taking something called as change in the condition. So for condition, let me tell you, I'm assigning a value here, I is equal to 1 and P is less than equal to N. Now, you will be thinking from where this P came. So P is a variable that will be declared outside this loop. Let me just, and this value will be incremented. So we are updating I increment. So like if we write here, P is equal to P plus I, simply. So P is equal to P plus I. So how do we do that? So basically, firstly, we will be declaring here int P is equal to 0. P is equal to. After declaring the variable int P is equal to 0, we will simply close this bracket and like how to proceed. Now here you can see the change in the question. Like it looks simpler, like compared to, like it looks quite similar to the one that we discussed in the start of the our time complexity topic. So like it is I is equal to 1 and this P is less than equal to N, then I plus this. So and inside the loop, it is happening P is equal to P plus I and this P is declared outside the loop. So like you can't blindly say that this loop will run for n plus 1 times and the time complexity of this program segment will be big O of n. You can't simply say this. So how we will do? So as I've told you throughout the time complexity topic, that when you can't call it as blindly, so you have to analyze it. So let me analyze it. So like the value of I will be writing and the value of P I will be writing. So the value of I here is initially the value of I is 1. And if we take the value of n supposedly, which is less than equal to, if even if we take a value supposedly n, and n is a value like 5, 4, 3, whatever you call at the moment, n is a value, n is a certain value, and initially I value is 1, and p value was declared here p is was equal to 0. So p satisfies the condition, so the loop, the control of the program will go inside the loop and there it is written P is equal to P plus I. So now the value of P becomes 0 plus 1. Then then after doing P is equal to P plus I, control of the program will go to updation. Updation is where I plus 2. So where updation is written, then the value of I becomes 2. Now the value of P becomes 0 plus 1 plus 2. When it becomes 3, the value of I becomes 3. Then the value of P becomes 0 plus 1 plus 2 plus 3. So in continuation, when the value of I and P becomes like when we take the value of I k, like kth time, when in the kth execution of the time, when the loop is iterating for the kth time, the value of P becomes 0 plus 1 plus 2 plus 3 till k. Now what it seems as of now, 0, even if we write or don't write, it hardly makes difference. Now, if we see this till kth time, like the answer is this 1 plus 2 plus 3 till k. Now, if we assume that the loop runs for kth time, now Why I'm making this assumption that the loop will be running for the kth time. So, based upon our question, it is obviously clear that this loop won't run for n plus 1 times. The value of a, this will not simply go from 1 to n. Like whatever n we are taking here, the loop won't go from 1 to n. So we obviously assume that the total number of times the loop will be running will obviously be k times. So if we assume that the loop is running for k times, so the loop will execute. Like here the condition was p less than equal to n. So obviously the loop will execute or the loop will stop executing when the value of p becomes greater than n. So when value of p becomes greater than n, then 1 plus 2 plus 3 dash 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 till k is greater than n. So now this is equal to sum of k and natural numbers. What is this? This is sum of k natural numbers. Now this is equal to k plus 1 by 2. Now this is by 2 and this is greater than n. So roughly when we calculate it, it will come like how much? It comes k square by 2 greater than n. So now when we take it k less than 2 root n. So now based upon the definition or based upon the method of calculating the time complexity, I told you the highest power of n or the degree of the polynomial you can call. Now degree in a polynomial is always taken in reference to the highest power, the highest degree term. Here the power of n is obviously 1 by 2, 1 by 2 is root. So simply if we write the time complexity of this program, then this is equal to big O of root n. So hopefully it's clear. If let me just revise it. So in this program, I have initialized a variable p is equal to 0, and I have taken the loop starting from I is equal to 1, and that particular value of p will reach till n, and I'm incrementing I by 1 every time. And inside the loop, I am actually doing p is equal to p plus I. Like I am adding the value of I to the variable p, and then we are supposed to take out the time complexity. So I have done now why I have done this process is like that. You know two things. Like you know that this program won't run for n plus one times. And the other thing that you know is that you can't say blindly or directly that the time complexity of this program segment is big O of n. So we have to analyze it. Now the method of analyzing is that here two variables are there. One is p, which is dependent on I. So initially when you take the values of I, you have to find out the values of p. Now, inside our program, the condition was p less than equal to I. So, this program will run till the value of p is less than equal to n. So, in that case, when the value of p is less than equal to n, till that time, the program will run, the loop will run, it will iterate, and it will soon stop iterating as soon as the value of p becomes greater than n. So, based upon our analysis, we are observing when the value of I is equal to 1, the value of p is equal to 0 plus 1. When the value of I is 2, its value is equal to 0 plus 1 plus 2, and so on. If we assume that the loop is running for k times, then its value will become 1 plus 2 plus 3 till k, which is equal to sum of k natural numbers. So we have taken here, and it comes out to be k into k plus 1 by 2 greater than n, which is very obvious. And then its time complexity comes big O of root n. So moving on to our last part of the question, that is while. Now, while here is something kind of, let me do for you. So how we approach the while? Like, let me tell you. Firstly, we will be writing here k less than equal to less than n or equal to n, take it. Here we will be doing it k is equal to k plus simply, mm, I will be doing here k plus 1 or I, and then I will be doing here I plus plus, and then I'm closing it and I'm writing here I is equal to 1, comma, k is equal to 0. So again, the question here is that how we will approach it. Now, if it's a very simple while, like if I'm doing here I is equal to 1 and I less than equal to 1, and sorry, I less than equal to n, and I is statement are normal there, it's not like anything. If we are not doing any kind of, like we are simply incrementing with I plus plus, we're not doing any kind of other thing with the updation process, then this will also simply run for n plus 1 times, and you can write the time complexity as big O of n. Or if the updation is happening, I is equal to I asterisk into 2, that is I into 2. So it will come log n base 2 times. Same goes for division. But when it comes something like this, then you know that this program won't run for I n plus 1 times. This program won't run for n plus 1 times. This you know. And the other thing that you know is, so therefore its time complexity can't be directly said that it is big O of n. So when it can't be said, then we have to simply analyze it. So when we are analyzing it, what we have to do? Again, in this question, we are dealing with two variables, that is I and k. So initially we will be writing the value I. It is quite similar to the question that we did with for loop. So I and k, when the value of I is 1, then k is assigned the value 0. And if it is here, k is equal to k plus I, it is written, then the value will become 1. Now I has been incremented by 1. So when I will become 2, then the value of k will become 1 plus 2 plus, like for this now, this will come as 2 only. So presumably, when we take the value of I as k, supposing that the program, the loop, the while loop will iterate for k times, for k times. So in the k time, that is in the last time the when the for loop will be iterating, we obviously why we, if the question arises in your mind that why we are taking the loop will only run for k times, so we know from the program that it won't run for n plus 1 times. So we are taking that it will run for k times. So in that assumption also, we are taking that if the when the loop is on the kth iteration, then the value of k will simply become 1 plus 2 plus till k. So again, based upon our observation, this is the sum of k, k, k natural numbers. So how we calculate it? We simply calculate it k into k plus 1 by 2. And how will be the condition determined? Based upon our loop, we are saying the loop will run when the value of k is less than equal to n. So in other words, we can say when the value of k becomes greater than n, then the loop will terminate. So we'll be writing here greater than n. And just like the previous question, this will come out to be the value k square greater than 2n. So just like the previous question, the value of k becomes 2 root n. Now, this simply decides the time complexity of the given function based upon its degree, that is the highest power term, is root n. So, hoping that I've cleared each type of problem with while loop, and for if is determined by the condition. So, the value of if, the statements written inside if are just based upon the conditional statement. So inside if the statements can be executed, but the values inside or the statements inside if will be executed for single time, like they have the time complexity O1. So we have to keep in mind the time complexities of if statements are O1, like they will be executed single time. And inside the if it is decided, if like in a common question, if you do for loop, if you place for loop inside a if, then that will determine the time complexity based upon the iteration. You are using some iterative code inside the if. Otherwise, if you are writing simple code, then inside if its time complexity is one time. It will check the condition and it will print, or it will take a decision simply. So that has its time complexity O1. So hoping that I've cleared all your type of time complexity questions and you will be able to do practice them. So now comes the priority chart, what I am going to write, and this will be the conclusion of the video. So priority chart. So this is the priority chart, and this priority chart contains the order. Like if you have been given two program segments and you have to decide which is efficient. So how you will decide? You will simply calculate the time complexities of both the program segments, and based upon the order that I'm writing here, you will decide which one is efficient. So initially comes big O of 1. Okay, big O of 1. And then comes your big O of log n. Base can be anything. Now I'm not mentioning here base. That doesn't mean that it doesn't have a base. I'm writing here 2, but that 2 depends on the type of constant that you are updating with or multiplying with. So then comes your root n. Then comes your O of n. Then comes your O2 to the power n. O 3 to power n, and so on. Now this is the time complexity chart. Now if I just clear it, this is not O of I kind of thing. This is simply O of 1. Now, this is very important priority chart. Now, based upon one of the questions in which there were two separate loops, and I just did the time complexity using the out of the two loops, we calculated the time complexities of both the loops individually, and then we decided how to take the time complexity of the overall program segment. Now, how we did that question? We did that simply like by checking the maximum time that which program segment will take, that will determine the time complexity. Now here the in the like if we ask what is which program is time efficient, now that was question based upon the time complexity of the overall function. Here when it is asked which program is code efficient is or is efficient, whatever you call. So in that case, you have to simply learn this chart, and this chart is in this order. Like it is in this order, and it simply increases in this order. So, like we say, if a code has its time complexity, let me tell you with an example. If a code has time complexity O1 and the other code has its time complexity ON, now then which one is better efficient? We all tell that code with time complexity O1. Similarly, if a code is having a time complexity ON and the other code is having time complexity O2 to the power n, or 2 to the power n. So out of these two, which code has which code is efficient? So it will be determined by the code which takes lesser time, whose time complexity is less. This will be ON. So simply don't get confused by the fact that we did over there. That was the question which had two for loops, one for loop, then another for loop. So in that case, to take out the time complexity of the overall program, we have to first calculate the time complexities of the individual codes, and then we have to determine the time complexity by the maximum there. Time complexity is simply the maximum time that is required by the programming program. So that is the case. So this brings us to the conclusion of our video. So hoping that it's clear. So this is the overall time complexity. So thanks for watching. Do share and subscribe. Stay tuned for more content. Thanks for watching.